We have three algebraic expressions here: u plus 2, u squared plus 2u plus 2, and u cubed plus 2u squared plus 2u plus 2. Now these three algebraic expressions are polynomials as well. These are polynomials. Okay. But of these three polynomials, only one is a linear polynomial. Linear polynomial in one variable. In fact, these three polynomials are polynomials in one variable. Okay, these are polynomials in one variable. Why? Because this is u plus 2, so only one variable is here. U squared plus 2u plus 2, only one variable, that is u here. U cubed plus 2u squared plus 2u plus 2, again only one variable, that is u. So these three are polynomials in one variable, and of these three only one is linear polynomial in one variable, and that is this one, u plus 2. And why? Because in u plus 2, in this polynomial, the degree is 1. Why degree is 1? Because u, that is the power containing the variable u, has the exponent of 1. So this exponent is 1, therefore degree is 1. In this case, that makes it a linear polynomial in one variable. Why this polynomial is not a linear polynomial? Because its degree is 2, because of these two powers, in these two terms, this one 2u and 2u u squared, of these two terms, this term has the power whose exponent is 2, right? So its degree is 2. In the same way, its degree is 3, because this term contains the power of the variable u that has the exponent 3, right? So degree 1, degree 2, degree 3, therefore that makes this linear polynomial, that makes this polynomial a linear polynomial in one variable. Okay, now what about this one? What about these 1, 2, 3 and 4 polynomial expressions? Are these expressions polynomials? Yes, this is also a polynomial, this is also a polynomial, this is also a polynomial, and this is also a polynomial. Now if you're wondering that why I am repeating this, that whether these algebraic expressions are polynomials or not, for that you have to check the previous video tutorial where we discussed how to check whether an algebraic expression is a polynomial or not. Okay, the main thing is, in short, the exponent, like here it is x, the exponent, the power should have the exponent that is a whole number. Okay, so all these four algebraic expressions are polynomials. Now, are these linear polynomials? Yes, all of them are linear polynomials. Why? Because this algebraic polynomial has two terms, 10x and 5. So 10x and 5, in this term, this x has the exponent of 1, therefore its degree is 1. In this case, you have two terms, 5 and minus 10x, right? Here also degree is 1. In this case, it is square root of 2x, again degree is 1. Same here, of these four polynomials, only 3 are linear polynomials, and in fact only 3 are polynomials. I'm sorry for this. This is not a polynomial. This is not a polynomial. Why this is not a polynomial? Because here it is actually square root of 2 plus x raised to power of minus 1, right? This is x raised to power of minus 1. This is not a polynomial, this is not a whole number. This is not a whole number, therefore this is not a polynomial, right? So only 3 are polynomials, and these 3 are linear polynomial in one variable. Linear, why linear? Because their degrees are 1. And why in one variable? Because these 3 polynomials are only formed by one variable, formed using one variable. Okay, so in general, if we have to talk about a linear polynomial in one variable, then we can write it as ax plus b, where a and b are constants and a should not be equal to 0. Okay, let's discuss this one by one. Why ax plus b? Well, you can see here, when your linear polynomial in one variable is represented in this way, where a and b can be constants. So you can take this example here, 10x plus 5. So in 10x plus 5, this is a and this is b. Okay, now if you take u plus 2, if you take this u plus 2, again in u plus 2 means what? 1u plus 2. So 1u plus 2 means that 1 is a, 2 is b. Again, ax plus b, ax plus b form. Don't go on this variable. You can take any variable. The only thing is that in general, if you have to write, then you can represent a linear polynomial in one variable in this form. You can take any variable. Okay, so again, if you want to take another one, let's take this 5 minus 10x. So in the case of 5 minus 10x, this is actually equal to minus 10x plus 5. So minus 10 is a, 5 is b. That is what written here. A and b can be constants, right? So a and b are constants in all these cases. Okay, now if you look at this one, that is square root of x. So in the case of square root of x, this is actually square root of x plus 0. Therefore your square root of 2 is a, 0 is b, right? Again, ax plus b form, right? Okay, now next thing, your a cannot be equal to 0. Okay, let's make, in all these cases, let's make the a 0. So in this case, if you make a 0, then this polynomial gets reduced to only 5. 0 multiplied by x means what? 5. Now 5 is a polynomial. Yes, it is a polynomial, but it's not a linear polynomial. It's a constant polynomial. Constant polynomial whose degree is equal to 0. Why? Because 5 means what? 5 is actually x raised to power of 0. 5x raised to power of 0 means that its degree is 0. Let's do in this case. Let's make a 0. So a 0 means what? This polynomial gets reduced to 2. Again, 2 is a constant polynomial whose degree is 0. Why? Because it is actually 2x raised to power of 0. Therefore, degree is 0. If you do the same thing here, if you make a 0, this again gets 5. Right? So the point is, your b can be 0, like in this case. Yeah, in this case, your b can be 0. If b is 0, then ax plus b means ax only. So ax is still a linear polynomial because it has a variable whose degree is 1, whose the degree of this polynomial is 1. That makes it a linear polynomial in one variable, right? That is why we have written here a and b are constants and a cannot be equal to 0. So that is the reason. So in general, if you have to represent a linear polynomial in one variable, this ax plus b is the way to represent it. Another thing, linear polynomial in one variable can at most they can have only 2 terms in a polynomial. At most, not more than that. They cannot have more than 2 terms. How? Okay. If you see here, in all these, like in this one, in this case, this is u plus 2, 2 terms. 10x plus 5, u 2 terms. 5 minus 10x, 2 terms. Here, under root, square root of 2x, only 1 term. It means that at most, so 1, that's completely fine. Since it's not a polynomial, therefore we don't need to discuss this. Then, yeah, we're done. So now imagine that someone writes like this. Someone writes like 5x plus 2 plus 9x minus 3x plus 4. So the person says that, hey, this is a polynomial. Sorry, this is an algebraic expression that is a polynomial, right? Yes, it is a polynomial because if you take the terms that contain the variables, so these are the 3 terms that contain variables. Now, x, the exponents in these 3 cases are whole numbers, that is 1, 1, 1. So that makes it a polynomial, completely fine. It's a linear polynomial, completely fine. But you will say that, hey, since it is a linear polynomial, but here we have 1, 2, 3, 4 and 5 terms. No, it doesn't have 5 terms. It has only 2 terms. Let me show you how. You know that a concept of like terms and unlike terms. Right. So 5x, 9x and minus 3x. These 3 terms contain variables x, right? And the same variable. They contain the same variable. So 5x plus 9x minus 3x plus 2 plus 4. These 2 are like terms. Why? Because these 2 are constant terms. 5x plus 9x is 14x minus 3x is 11x and plus 6. So it's of the form ax plus b. Again, at most you have only 2 terms. So don't get confused. Well, whenever you look at any algebraic expression, always try to add up all the like terms, right? So whether that term contains the variable or whether the terms contain the same variable or they are constants. You have to add them together and then you can see whether that is how many terms that algebraic expression or that polynomial contains.